So hello, my name is Isaac and today I will show you a short project where I use linear regression in Python to predict house price from size in square meters. I'll explain what the model is, go line by line through my code, and show what I observed when I ran it, and give you simple conclusions about how well it works. But first of all, what is linear regression? Linear regression is a way to fit a straight line that links an output house to an output y, price. Once we learn that line, we can type a new size that to get a new price estimate. We train the line with a gradient descent, which is like walking downhill on an error curve until we reach the lowest point, the best fit. Now let's take a look into the code. First of all, we import the libraries. Import nump as in np, import pandas, and import matplotlib. NumPy does fast math, panda reads the file, and matplotlib makes plots. Now we have to load the dataset. This reads my CSV from the correct path on my computer. I take the tamaño or size as input and precio and price as a target. Now we have to define the cost error function. This is the half of the mean square error. Lower cost equals better fit. Now we call the gradient descent or how we learn the line. So basically we predict, measure the error, and nudge the line a little to reduce that error many times in a row. Then we have to train the model and print the results. Theta, we have the theta, cost history, theta 1, theta 2, gradient descent, and we have to print the values that we use that were shown before. So here, this gives the learn, intercept, and slope for the standardized x. Then we have to model or evaluate with a model with MCE. MCE is the mean squared error. On the training data, it tells how far on average the predictions are from the real prices in square price units. Lower is better. So now we make a prediction for a new size. I standardize a new size with the same mean and the standard deviation, then apply the line. If I type a bigger size, the predicted price goes up. A smaller size gives us lower price. That's the expected behavior. Now here we're going to plot the cost curve. The cost goes down and then flattens. That means that the model is converging correctly, and at first at big improvements, then small ones, and then it levels off. So now we're going to run the code, and as you can see here, this graph will be printed. That will be the price and the size, and here will be the next values, the training MC, the predicted price, and the values after the gradient descent. My observation when I ran it, the cost chart drives smoothly and then flattened at the end, so training behaved normally. The printed MCE gave one clear number for the training error. Because prices are large, the MCE number is also large. Thus the normal sense it is in price square units. The prediction for 400 square meters look reasonable. Smaller size gives a lower price compared to a larger size like 320 square meters. That matches common sense. Conclusions about the model's effectiveness. The simple linear model is effective when the relationship between size and price is roughly at a straight line. With normalized input and steady settings, the model converges and produces sensible predictions. The MCE summarizes the fit on the training data, and the cost chart confirms the learning worked as expected. If the new size is inside the data range, the prediction is more reliable, interpolation. If it's outside the range, it is an estimate but less certain, extrapolation. Overall, for these stacks, the model meets the goal. It learns a straight line trend and makes quick, understandable predictions. Thank you for watching, and I will see you next time.